Welcome to the Bentley Institute Quick Start training course in analyzing bridge projects in Iron Bridge. In this lecture you will learn how creep, shrinkage and relaxation effects are handled within Iron Bridge. We continue with the model of the previous lecture. Even if creep and shrinkage is calculated more or less automatically, we have to prepare loading cases to store the results. And as usually, we start the definition of the loading case with the preparation of the load management. Therefore, we go to Schedule, Load Definition, Load Management. We insert a new line in the upper table. We call our load management label creep and shrinkage, CS. We sum up the creep and shrinkage results in a summation load case called CS minus sum, and also in our summation load case stage minus sum. We continue the definition of the loading case itself. We will consider three creep effects, one in stage 1 of the pier alone, one in stage 2 due to the self-weight and the pre-stressing on the main girder, and finally in stage final we will calculate the infinite creep. So we define a new loading case. Let's call it CS minus stage 1. It is permanent. The meaning of permanent is only loading case that have a permanent character, a duration type permanent, are considered in the creep and shrinkage calculation. So this is the moment where we can check if all the loading cases that we have applied on the structures are permanent. Yes, they are. So we can go on here. The load management for this loading case is CS, and we give a description, creep and shrinkage, stage 1. No further input in the bottom table is required. Now we can prepare the other two loading cases by copying this one. So we mark creep and shrinkage of stage 1, make a copy, call it creep and shrinkage of stage 2, also in the description. And for the infinite time increment, we make another copy, we call it CS infinite, and in the description time infinite. Now we execute the creep calculation in our schedule. Therefore we go to the stages and we start here with the activation. Here it is important to mention that the age of the elements have an influence on the creep effect. The age of the elements has the meaning this is the age of the concrete when the load is applied on the structure. So in stage 2 we change the age of our main girder elements to 28 days. So the concrete has an age of 28 days when the pre-stressing is applied on it. And similar, we change the age of the elements of our pier, which are the elements 1201 to 1204. We change the age to 42 days. Now, the calculation of the creep effects is done as a schedule action. In stage 1, after we have calculated the load effect of the self-weight of the pier, we insert a new schedule action. The schedule action is called creep. The load case where we store the result is the load case creep and shrinkage stage 1. And the time step for which we will calculate the creep effects is 32 days. The same we do in stage 2. At the end we insert a new line. To calculate the creep effects, we use the schedule action creep. The load case to store the result is our creep and shrinkage in stage 2. And the time step is 28 days. And in stage final, we apply the infinite creep. So again, new schedule action of type creep. The load case to store the result is creep and shrinkage for time infinite. The duration of the creep effects will last 10,000 days, which is approximately 25 years. And to get better results, we subdivide this time increment into 5 time steps. Now we can calculate our project and have a look on the creep results. Press Recalc. We consider now the time effects and we include the relaxation, and for the relaxation we need to define our summation load case in the recalc bed. So this is loading case stage sum. And for a better approach of the infinite creep, we change the creep and shrinkage parameter from a linear time stepping to a logarithmic time stepping. We press Recalc. And we can in the user interface have a look on the results. So view options, select the results of our summation load case for creep and shrinkage. And we see the bending moments which are caused by the time-dependent effects creep, shrinkage and relaxation.